Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today, uh, I, I will take a class after so many days. That is after I think 1 week or 10 days of break because I went for my marriage. I got married, so that's why your class is disturbed. But you have got the video lectures, recorded video lectures per day per class. So there is no wastage of time of yours. All right. So today I'm going to continue with the same module, that is the procedure programming module. Only two or topics or three topics are left. Uh, so in the last class we have discussed about how to handle. Okay, thanks for lesson. Okay, thanks a lot. Um, in the last class we have discussed about how to handle the multiple signals, how to get the multiple signals and how to use the multiple signals. So let's start a quick review what we have covered in the last class and then moves to the next part, that is the today's topic, that is the event driven programming. So let's move to the last class topic. In the last class, that is your recorded lectures, we have discussed about how to handle the multiple signals, that is how to use the multiple signals, how to get the multiple signals that is used over here. Right. This is a program that is used, that is how to use the multiple signals or how to handle more than one signal at the same time. This is the program. These are the various header files that is used, that is unistd .h, systypes.h. These are the various header files. Signal.h. Then there is a void int handler, that is the initialization of the handler that is used, that has a data type or that has a argument, that is the int sig num. So these are the various argument that is used for the day-to-day scenarios. Then there is printf, that is a sig int received, that is a signal or a signal interrupt received. So this is a program. Then there is a function, that is a term handler, that is how to handle the signal term, that is a sig term handler. Then void count handler, int sig num. Then there is a printf sig count received. Then there is a int main. This is the main function. This is the function calling. So this is the function calling, that is a signal sig int handler. So these are the two arguments that is used. This is a signal. So whenever there is a function calling, this directly jump to this one. If this function calling second one, so that it directly jumps to second one, like this one. Then this one. So these are the various arguments, these are the various functions calling, and we can use by declaring the function, by using the function, that is the int handler, term handler and the count handler. Then there is a while one, that is your continuation of the program. Then printf program running. Then there is a return 0. So these are the various argument, these are the various signals that is used for creating the main function. And we have also discussed about the explanation of this program, that is how we are using this program or what is the usage of this program. So this is the detailed explanation of this program. There is a sig int that is used for creating a new signals, that is namely sig term and the sig continue. Then the sig function or the signal function is called thrice. Why thrice? One is used for the sig int, one is used for the sig term and one is used for the sig continue. So these are the three signals that is used. After registering the signals, we enter an infinite while loop. That is, we have also used the while loop one, that is while one. Then there is a printf program running. That means it is executing n number of times to print the program running message on the screen. As in the previous program, here too we have pressed Ctrl C for sig int, that is the int handler is called. So that is, we have used or we have pressed the Ctrl C for the handler for the sig int, that is a signal interrupt. So whenever we try to kill the program from the second terminal using the kill command, the program does not terminate. That is, this is because when the kill command is used, it sends the running program a 6-term signal. Then next point says once the execution of the term handler function is over, the program resumes its execution and continues to print program running. Then how we are supposed to terminate the program. So this is the key, or this is the command that is used to kill the program or kill the function, that is a kill sig kill 3276. So this is the command that is used for the killing the signal from the other terminal, that is at the same time killing the signal from the other terminal, that is a sig kill. So this says the sig kill signal is to be used as a last resort to terminate a program that gets out of control. So this is used, that is a sig kill signal is used to use as a last resort. As a last resort means as a last part to terminate a program that gets out of control. That is whenever there is a requirement to terminate the signal from other terminal, that is done by using the sig kill, or that is done by using the kill command. Then we have discussed what is the usage of control chat. Then we have discussed about the new topic, that is how to register a common handler. That is, what is the purpose of registering a common handler. So this says instead of registering a separate handler for each signal, we may decide to handle all signals using a common signal handler. That is, instead of instead of registering a separate signal every time, each time, then we may also decide to handle each and every signal using a common signal handler. That is shown in the program. So this is the program that is showing, that is hash include unistd.h, systype.h and signal.h. Then there is a void sig handler, then int signum. So this is the argument that is used. Then there is a switch, then signum. Then these are the content of the various cases. First case is signal interrupt. This says signal receive break. Then next one is sig term, that is a signal term or termination. So one is interrupt, one is termination, one is continuation. Then next case is signal term, that is your termination. Then printf sig term received. Then there is a break. Then next one is your case, the sig count, then printf sig count received, then there is a break. And these are the various closing curly braces that is used for closing the signal. Then there is a int main, that is the starting of the main. Then these are the three functions that is used. One is a signal, that is a sig int, sig handler, then sig term, sig handler, sig continuation, sig handler. So one is for interrupt, one is for termination, and one is for interrupt and continuation. This is the same. We also discussed the explanation of this program, that is how to execute or how to use this program. This is the detailed explanation of this program. We have used the switch case construct to print a different message for each of the three signals. That's why we use the switch case over here. One is signal interrupt, one is signal termination, one is signal continuation. Note that we can easily afford to mix the two methods of registering signals in the program. That is, we can register separate signal handler for some of the signals and a common handler for some other signals. Registering a common handler makes sense if we want to react to different signals in exactly the same way. Then we also discuss one topic, that is how to block the signal. This is very easy topic. There is a simple program. What do you mean by blocking first of all? This says blocking refers to or defers the delivery of signals to a process till the execution of some critical condition code is over. Blocking means block the signals to the delivery of the signals, or block the delivery of the signal so that it get interrupted till the execution of the critical code, or till the execution, or till the time the execution of the critical code is over. So instead of completely ignoring the signals or letting the signals interrupt the execution, it is preferable to block the signals from the movement and deliver them some time later. That is, block the signals and deliver at the later stage. Let us now write a program to understand how to use the signal blocking. So these are the various header files, that is hash include unistd.h, sys types.h, signal.h, stdi.h. So these are the four header files that is used. Then there is a void sig handler int signum. Then there is a switch case signum. These are the various cases. One is a sig termination, that is a signal termination. One is a signal interrupt, and one is a signal continuation. So whenever we use the block the signal, instead of using the signal interrupt at the first stage, at the first case, we have used the signal termination at the first stage. Why? Because first of all we have to terminate the signal, then move to the signal interrupt. Then there is the int main, that is continuation of the main. Then there is a char buffer 80, that means array is declared of the char type, that is string, that is of 80 characters, that is from 0 to 79, that is equals to null. That is, we have defined it as a null, that is it has continued till the null operator is received. Then there is a sig set t block. Then there are three signals or three types. There is sig term, sig handler, sig int, sig handler, sig continue, sig handler. Then this is the block that is used, that is a sig empty set ampersand block. Then this is a sig add set ampersand block sig term. This is sig add set ampersand block sig int. Then this is the new signal, this is the new function that is used, that is a sig proc mask sig block ampersand block null. Then this is the next looping that is used, that is a while loop is used, that is used for comparing the string, that is strcmp, that is a string comparison. What are the two content, or what are the two types, what are the two strings that is compared? One is the buffer, one is the end. So there are two types, that is the string will be continue or will be compared. One is the buffer and one is the n, and n contains one string that is used. And check the condition. It is, if it is not equals to 0, then simply printf enter a string which is not equals to 0, that is they are equal or they are not equal, then simply enter a string, then gets into the buffer and puts into the screen, that is the puts buffer. Then again this is the sig proc mask sig unblock ampersand block null. Then this is while one, that is continuation of the program, that is displaying the function, that is the program running. Then there is a return 0. In this program we have registered a common handler for the sig int, sig term and sig continue, or sig called signal. So we have used the same continuation, or we have registered a common handler for the sig int, that is the signal interrupt, signal termination and the signal continuation of the problem. Next we want to repeatedly accept the string in a buffer, that is, this is the explanation how we are using the sig proc, how we are using the sig interrupt, how we are using the sig continuation. So there are library functions that helps to populate the sig set t structure. The sig empty set empties a sig set t variable so that it does not refers to any signal. After the loop we have also used an indefinite while loop, that is a while one, to print the message, that is a program running. And we also use the control C for killing the command, for killing the signals when the signals are blocked. Now moves to the next topic, that is a today's topic, that is the event-driven programming. That is how to do the event-driven programming, or what is the event-driven programming. So this says, having understood the mechanism of signal processing, let us now see how signaling is used by a Linux. That is how different signals is used in a Linux. That is the event-driven programming. Is used by the Linux-based libraries to create the event-driven GUI programs. So these are the there are various signals, there are various mechanisms that is used for the signal processing, that is used for the signaling, or that is used for the various signal that is used by the Linux. base library to create the various event-driven GUI program, that is a graphical user interface program. As you know, in a GUI program, events occurs typically when we click on the window. So whenever we click on the window, there is a GUI program event that occurs on the window. Type a character, close the window, repaint the window, etc. So there are various programs or there are various events that occurs, like typing a program, repainting the window, type a character, close the window. We have chosen the GTK library version 2.0 to create the GUI applications. Here GTK stands for GIMS Toolkit. Given below is the first program that uses the toolkit or that uses the GTK, that is your GIMS Toolkit, to create a window on the screen. So this is the program that is used to create the window, that is the GUI program that is based on the event-driven programming. This is the header file, that is the hash include gtk.h. So this is the header file that includes or that contains various library functions that is used for the event-driven programming. Then there is a int main. Then there are various argument. One is the int argc, next one is the char pointer argv. So two macros are used. One is the argc and one is the argv. Then there is a GTK widget pointer p. So these are the various options that is used. That is a GTK widget option p. That is, we have first of all starting with the int main, that is starting with the main function, then simply uses or simply declare the pointer, that is the GTK pointer p. So first of all we have used the int main and we have used two arguments. One is argc, two macros, one is argc and one is argv. Then there is a pointer that is declared, that is GTK widget pointer p. So this is the pointer that is used, that is a pointer p. Then there is a GTK init. So this is the first function that is used, that is a GTK init. Then there is a argc and there is a argv. So in the brackets there are two options, there are two arguments, there are two macros. One is the address of the argc and one is the address of the argv. Then uses p equals to GTK window new. That is GTK window new is a function that is used and the output of this is stored in the p variable. And what are the argument that is used with the GTK window new? One is the GTK window top level. Then next one is GTK window set title. So this is the next function. There are two arguments in this. One is the p sample window, that is using the GTK, that is your toolkit, that is your GIMS toolkit to refers to or to creating a sample window or creating a structure of the sample window. Then G signal connect, p destroy, GTK main quit null, GTK widget set size request p 300 300. So these are the various dimensions through which we can refer or we can create the windows or we can reference the window or we can create the structure of the window, that is GTK widget set size request. Then there is a GTK widget show, that is p, that is using the GTK widget show function, that is, and the argument is p. What is p? That contains the function or that contains the window new function, that is the GTK window new, and what is the argument that is used is GTK window top level. Then there is a GTK main function. This is the GTK main function that is calling. Then there is a return 0. Now this is the int main function. Now let's see the definition of all these functions, how these functions will work. This says we need to compile this program as follows. So this is the procedure. GCC is the syntax or the command level or the scenario, that is prompt that is used, that is GCC Then there is a my window.c. So my window is the name of the window that is created, and then there is a .c, that is a C file, that is a that have extension .c. Then pkg config gtk plus minus 2.0 C flags libraries. Here we are compiling the program, that is mywindow.c, and then linking it with the necessary libraries from the GTK toolkit. So first of all, we are compiling the program. What is the name of the program? That is a mywindow.c, and then link this program, or link this program, that is a mywindow.c, with the necessary libraries. What are the necessary libraries? That is a pkg config C flags libraries. Note that codes that we have used in the command. These are the various codes that is used to connect with the mywindows.c. Here is the output of the program. This is the output of the program. First of all, there is simply a sample window in the title bar. This is the blank window. The GTK, that is a GIMPS toolkit library, provides a large number of functions. That is, there are a large number of functions that makes it very easy for us to create GUI program. That is, that makes it very easy, or that makes it very clear to create the GUI program, that is a graphical user interface program. Every window contains under GTK is referred as a widget. So each and every window that is available under the GTK, that is a GIMPS toolkit, is known as the widget. So every window is known as widget. To create a sample window or simple window, we have to carry out the following steps. These are the various steps that is used for creating a simple window. The first step is initialize the GTK library with a call to the GTK init function. That is, first of all, initialize the GTK library function, or initialize the GTK library by calling the new function. What is the name of the function? That is a GTK init function. This is the function that is used for creating the GTK library. This function requires the addresses of the command line argument that is received in main function. So this requires the argument, that is a GTK main function, that requires for the GTK main function. Next, calling the GTK window new function. That means, or this means, this is the definition of, or this is the explanation of each and every function that is used. First of all, GTK p, GTK init, now GTK new, then GTK window set title. So these are the various explanation of this program. The next point says we have used the GTK window new function. So this is the new function, or GTK new function, that is also used in the program to create a top level window. So first of all, in first point, it is used as a GTK init function for initializing, or for calling the GTK init function for using with the for initializing the GTK, that is a GIMPS toolkit function. Then calling the GTK window new function to create a top level window, that is using this function to create a top level window for creating a top level. The only parameter that is used, or that only parameter this function takes, is the type of the windows to be created. So this is the function that takes only one argument, one part, or one level, or one parameter, that is the, either we can use the top level window, either we can use bottom level window. That is the type of the window that is to be created. A top level window can be created by specifying the GTK window top level. So this is the argument, this is the parameter that is used, that is the GTK window top level value. This call creates a window in memory and returns a pointer to the widget object. So this call, that means the whenever we use the GTK with top level, that will use, or that creates a window in the memory and returns a pointer to the widget object, that is used in the programming, that is used in the GTK. The widget object is a structure, the GTK object variable, that stores lots of information, including the attribute of window it represents, including the attributes that is used, or that is including in this one, that includes various parts. We have collected this pointer in a GTK widget structure pointer known as the P. That means we have, first of all, we have used the GTK init function. Then we have used the GTK window new function that is used for creating the top level window that has various arguments. One of the argument that is used is the GTK window top level. Then we have also used one pointer, one function that is a P that is used to store the functions in a P, or that is used to store the output in the P, that is a variable. Next, C.8 set the title for the window by making a call to the GTK set title function. So first function is GTK init, next is GTK window new function, next is your GTK window sets title function. So this is the next function that is used for making a or that is used for making a title, or that is used for getting the title, that is the GTK window set title function. So first of all, initialize the GTK, then creating the structure of the window, then uses the title for choosing or for creating the title of the window. The first parameter of this function is a pointer to the GTK widget structure representing the window for which the title has to be set. The second parameter is a string. So the first parameter is the pointer to the GTK structure that is representing the window for which the title has to be set. The second parameter is a string. So one is the title that is to be set. The next parameter is a string that describes the text to be displayed in the title of the window. So this is the function. Title function is used for creating the title of the window. Then fourth point says register a signal handler for the destroy signal. That is next step is register a signal handler for the destroy signal. So we have used the destroy signal for registering a signal handler. The destroy signal is received whenever we try to close the window. The handle or handler for the destroy handler signal should perform cleanup activities and then shut down the application. GTK provides a ready-made function that is known as the GTK main quit function. So this provides a ready-made function that is available that includes the GTK main quit function that does this job. That is GTK quit function or GTK main quit function is used, that is a ready-made function that is used for destroying the signals, or that is used for destroying the signal handlers. We only need to associate this function with the destroy signal. This can be achieved using the G signal connect. So this is the signal that is used, that is the G signal connect function. The first parameter of this function, that is G signal connect function, is the pointer to the widget for which destroy signal handler has to be registered. The second parameter is the string that specifies the name of the signal. So now let's see what is the G signal connect function. So this is first of all GTK window new, that is the top level. Then GTK window set title, this is the name of the title, that is a sample window, and this is P, that is the P argument is used. Then signal connect, first of all there is a P, then there is a destroy, then GTK main quit function, then there is a null. There are four parts. One is P, then destroy, then quit, then null. There are four parameters in this one. So this says GTK provides a ready-made function, that is a GTK quit function, that is used in the as an argument of the destroy function. This can be achieved using the G signal connect function. The first parameter that is used is the pointer to the widget for which destroy signal handler has to be registered. The second parameter is a string, that is a string that is used that specifies the name of the signal. The third parameter is the address. We have not used the fourth parameter. Next point says whenever we want to resize, that is resize the window to the desired size using the GTK widget set size request function. So whenever there is a requirement to resize a window, that is done by using the function. What is the name of the function? That is the GTK widget set size request function. So this is the function that is used to resize the window to the desired size as per my requirement. The second and the third parameter specifies the height and the width of the window respectively. So these are the various height and the width. First of all, there is a height, then there is a width. That means 300 width and the 300 height. And this is GTK widget set size request. Next point says display the window on the screen using the function that is a GTK widget show function. So first of all uses the GTK init, then GTK init function, then GTK show new function, then GTK title function for creating the title, then the GTK quit connect. Next is your GTK show function to display the window on the screen. Waiting for a loop or waiting a loop to receive events for the window. This can be accomplished using the GTK main function. That is, next part is receive the event for the window, or receive the event for the window that is created, that is accomplished, or that is done by using the GTK main function. How about another program that draws a few shapes in the window? Here is the program, myshapes.c. This is the program that is how to draw the shapes in the event programming. So first of all, there is a hash include gtk.h. So this is the header file that is used, that is the Jim's toolkit, that is the gtk/gtk.h. Then there is a int expose event. So this is the name of the event, or this is the name of the function that is used. One is the expose event, and the return type is int. Then there is a GTK widget pointer widget. So this GTK widget is also the parameter, and this is the pointer, that is a pointer widget. Then GTK event expose, then there is a pointer event. So this is first of all GTK widget. This is the like a data type, that is the type of the data is of GTK widget, and the pointer variable that is used is the widget. Then GTK event expose, and the pointer that is used is the pointer event. Then a new pointer is used, that is of GTK GC pointer P. Then GTK point array 5, that means it contains the it is of array 5, that is of type GTK point, that is 250, 150, 250, 300, 300, 350, 400, 300, 320, 190. But remember, this is not correct. Why? Because this is 5, but we have used 1 2 3 4 5 6 7 8 9 10. This is not correct. This is either 15 or either 10. So this is 15. Assume it as a 15, because as I told you, whenever we declare the array, the number of the elements are not more than the dimension of the array. Here the dimension is 5, but the number of the elements are 10. So that is not valid, or that is not acceptable, or that is not error free. Then uses a new function for creating the window, the same continuation of the function, that is a GTK GC new. Then there is a argument that is used is the widget window. Then GTK draw line, then the argument is widget window P 10 10 200 10. So these are the various arguments. One is a widget window, then there is a P, then there is a 10, then there is a 10, then there is a 200, then there is a 10. So these are the various dimensions for drawing the line. So first of all, there is a GTK GC new and function, that is function calling, that output of this is stored in the P. Then next is your drawing a rectangle, that is the GTK draw line. Then there are various arguments, that is a widget window P 10 10 210. Then GTK draw rectangle, that is used for drawing the rectangle, that is also event programming. Then widget window P 3 10 20 210. So these are the various rectangle, or these are the GTK draw rectangle that is used to draw the rectangle. Then GTK draw arc. So this is the next part, that is how to draw the arc, that is using the GTK. Then widget window P 2 200 10 200, 200, 2880 minus 2880 into 2. So these are the various dimensions that is used for drawing the arc. So one is used for drawing the rectangle, one is used for drawing the line, one is used for drawing the arc. The next part is GDK draw polygon. The next part is used for drawing the polygon, that is used for drawing the polygon. And the argument that is used is same, the widget window. That means first of all creating the widget window, then draw the shapes like line, rectangle, arc, polygon. And there are various arguments like P, Q, ARR, 5. Then the next part is GDK, GC, unreference, that is unref. Then there is a variable, there is an argument that is P. Then the next part is return true. So these are the various arguments, these are the various functions that is used. So one is GDK, GCC, pointer P. Then using the new function, then drawing the lines, then drawing the rectangle, then drawing the arc, then drawing the polygon, then drawing the unref, that is P. Then at last there is a return 0. Now this is the main function, that is the int main. So this is int main, int argc, char pointer argv. So this is the main function, that is a return type of the int. And there are two macros, there are two arguments that is used. One is the argc and one is the argv. Argc is of int type and argv is of pointer, that is of char type. Then there is a GTK widget pointer P, that is a pointer is used, pointer variable is used, that is a GTK widget, then there is a pointer P. Then GTK init, that is the initialization of the GTK. Then there are two arguments again, the address of the argc and the address of the argv. Then this is again for creating the new window, that is a GTK window new. The same, the window, GTK window top level. This is the dimension that is used, that is creating the window that is of top level. Then setting the title of the GTK window, that is a GTK window set title. And there are two arguments that is used, one is the P, one is the sample window. Then G signal connect, that is the next part, that is a G signal, that is a GTK signal connect. And there are various arguments, that is P destroy, GTK main quit, null. Then G signal connect, P expose event, null. So these are the various arguments for destroying the event, for exposing the events, for setting the title of the window. Then there is a GTK widget set request or set size request, that is used for setting the size of the window, that is P 500, 500. First 500 is used for the height and next 500 is used for the width. So one is height, one is width. Then uses the show function for showing on the screen, that is the GTK widget show P. Then there is a GTK main function, that is including the main function of the GTK. Then there is a return 0. This is the output that is given below. First of all there is a rectangle, then there is a polygon, I think. So we have used three lines. One is the for creating the title, that is a G window. Then there is a set request, that is the polygon, arc, and this one. This is the line. This is the rectangle. This is the arc. This is the polygon, and there is a sample window. These are the four content that is used or that is created over here. This is the explanation of this program. So this says this program is similar to the first one. The only difference is in addition to the destroy signal. So this program is very similar to the first one that we have used, but the difference is that addition of the destroy signal for destroying the signal, that is that we have registered a signal handler for the expose event using the G signal connect. So how to destroy the signals? By using the expose event, by using the event, by using the G signal connect function. This signal is sent to our process whenever the window needs to be redrawn. So this signal is sent to our process, to our requirement, whenever the window needs to be redrawn, or whenever there is a requirement that the window need to be redrawn. By writing the code for drawing the shapes in the handler for this signal, we are assured that the drawing would never vanish if the window is dragged out the screen and then brought back into. That means writing the code for drawing the shapes also ensures that the drawing would never vanish, that the drawing would never vanish or the vanish if the window is dragged outside the screen. That is, if the window is going outside the screen, that also sure that the drawing will never go outside the window and never brought back in, or some other window uncovers a portion of our window which was previously overlapped and so on. So this is the case whenever we create the, or whenever we draw the windows. This is because an expose event signal would be sent to our application, which would immediately redraw the shapes in our window. So this is also the signal that is used, that is the expose event signal, that is used for reshapes the or redraw the shapes in case if there is any unfortunate error will occur. So this will unfortunately, or this will immediately redraw the shapes in our window. The way in Windows we have a device context, under Linux we have a graphics context. In order to draw in the window, we need to obtain a graphic context for the window using the GTK GC new function. So this is the function that is used, that is the GTK GC new function for drawing the shapes of the, or drawing the shapes in the window. This function returns a pointer to the graphic context structure. This pointer must be passed to the drawing function, or this pointer must be used with the drawing functions like GTK draw line, GTK draw rectangle, arc, polygon, etc. These are the various functions that is used along with the pointers. That is a line, rectangle, arc, polygon. Once we are through with the drawing, we have released the graphic context using the GTK GC and reference function. So these are the various functions that is used. One is the line, one is the rectangle, one is the arc, one is the polygon. So after drawing the shapes, we have released the graphics context using the GTK GC and reference function. Where do you go from here? This says, where do you go from here? You have now understood signal processing, the heart of the programming under Linux. So this is the main important part, that is the heart of the Linux programming, that is the event-driven programming. With that knowledge under your belt, you are now capable of exploring the vast version or vast world of the Linux on your own. Complete Linux programming deserves a book on its own. Idea here was to raise the hood, should what lie underneath it. I'm sure that you have taken a good look at it. You can try the rest yourself. Good luck. This is the closing of the event-driven programming, closing of the Linux programming. That is how to use the Linux programming. Now let's take a break over here, and after the break moves to the practical approach, that is how to do the practical approach in this one. That is a practical of the C programming, that is a DOS-based programming. After so many days, so let's take a break first of all, 10 to 15 minutes, then move to practical approach. All right. Come back from the break. Let's move to the practical approach. So now I'm going to start with the practical approach of the functions, that is how to use the functions with different operators. What is operators? That is equals to, plus, minus, divide, multiply, that is addition operator, subtraction operator, multiplication operator, division operator, equals to operator, that is the assignment operator, increment operator, decrement operator, modulus operator, conditional operator. So there are many operators that is used that we can use with the functions. So let's start with the program. Let's start with the practical approach, that is how to use the functions with the or how to use the operators with the functions. So first of all, there is the hash include stdi.h, then there is the hash include conio.h, then there is a void main, the same. Then first of all, this is a program, that is how to assign the return type of the function, that is how to use the assignment operator, that is how to assign the return type of a function to another variable. This is the case. So this is the program. To another variable, right? So there is a void main, this is void main, then there is a curly braces. Now there is a function that is used, that is a int, then there is a input, then in bracket there is a int. So that means input is a function that has a argument, that is a int, right? Then there is one more variable that is declared, that is x, then there is a clr, scr for clearing the screen, then there is a assignment operator that is used, that is assign the return type of a function to another variable. So this x equals to, then there is a input, then in bracket there is a x. That means x is used as a return type to the another variable, right? Then simply uses the printf for printing purpose, that is percentage n, sorry, slash n, that is x equals to percentage d, then there is a x. Then this is the closing of this one. So first of all, we have to use the get ch over here. Then there is a closing of this one, and this is the function that is used, that is the input. Input is the function, and the return type or the argument that is used is k. Then there is this one, then there is a printf for printing purpose, that is enter value of x, then there is a scanf, then again there is this one, that is percentage t ampersand k, then there is a return k, that is return k is available over here. Then this is a closing of this function. Now if I compile this code, there is zero error. If I execute this code, enter the value of x, for example I have entered the value of x as 5, the output is x equals to 5. Now let us understand what is the how we are using the value of x, how we are gathering or how we are taking the value as it is, that is x equals to 5. So this is the program that is used to assign return type of a function to another variable. So there are 4 or 5 variables, or there are one variable that is x that is used to take the return type of a variable to the another variable. So first of all, there is a hash include stdi.h, then there is a hash include conio.h. These are the various header files that is used. Then there is a void main for main function. Then there is a int input int, that is input is the name of the function and the int is the argument, int is the parameter that is used, and this int is the parameter, that is the variable that is used in this one is of integer type, and this int is of return type. Then there is a variable that is declared, that is of x, that is of integer type. Then there is a clear screen for clearing the screen. Then this is the input function, this is the input x, that means this is the function, this is a function calling that has a variable that is x, and the output is stored in the x. That means the same, the argument is also x, the variable that is also used as a x, and the output is also stored in the x. That means the same variable is used for the as an argument, and the same variable is used as an return type, right? Then there is a printf that is printing the value of x, that is the x. Then there is a get ch for displaying the output. Then there is a input, then int k, that means the variable is declared and the input is the name of the function. Then int k, that means the declaring the variable, that is a k. Then there is a printf, that is simply entering the value of the from the user, that is printf enter value of x, that is getting the user or getting the value from the user. So this is the explanation of, or this is the definition of this function, and the output is stored in the x, that is input int k. That means k variable is used for storing the input or for storing the output, take as an argument. Then there is a printf, that is enter the value of x. Then there is a scanf, that is ampersand k. Then there is a return k, that means returning the value of k into this one, that is return k. Then this whenever there is a this statement, that is return k, is approaching, that means the output is, or the cursor moves over here and the output is stored in the x, and then prints the output over here, that is x. So in this as per my example, user have entered the input as a 5 and the output is displayed as a 5. Why? Because 5 is available over here, 5 is available over here, 5 is available over here, 5 is available over here. This is the program to just show how to use the assignment operator with the function. This is the function, that is how to use the return type, or how to use the another variable as an assign, or how to assign the return type of a function to another variable. This is the return type, this is the return of k, how to assign to the x. This program is clear to you, Alison? Yeah, Alison, this program is clear to you? Hello, Alison, this program is clear to you?